A very good morning to the respective panel. I'm Sri Selva Prakash and today I'm going to explain about my final year project, which is development of real-time vehicle identity database at tollgate using RFID technology. As an introduction, this project is basically about a system that develops a database which stores the information of the vehicles passing the toll gates. So let me quickly jump into the project background. Every day millions of vehicles actually passing by the toll gate, but there is no any system that creates a database of collecting the information of the vehicles that passing the toll gates. Let's for instance, for an example, like in IEEE toll gate means what time, how many cars and what car actually passed by, the car plate number, the car details, the car model. So there's no actually any system that acquiring those informations and making it in a database. When we look at the current solutions for this problem, the first one is the ANPR, which is known as automatic number plate recognition using camera technology. Basically how it works is the ANPR camera actually takes an image of the number plate of the vehicle, then it will be passed to a reader. With the help of the special algorithms like optical camera recognition, the system actually able to extract the alphanumeric from the number plate, like BND5610 like that, and this data will be then searched within the record database to acquire the information of the vehicle. The pictures below showed like how roughly it will detect the number plate and extract the alphanumeric. But when we look at the limitations of ANPR system, the first one is the image quality. Low image quality captured by the camera due to the moving speed. When the car is moving and is capturing means the picture gets blurry, which is ends up in the low quality, which makes it harder for the system to actually get the alphanumeric number. The second one is the various environment conditions like rain, pollution level, lighting intensity, which makes the environment different at different times, makes the camera actually difficult to actually extract the alphanumeric number, because the image taken was actually different lighting, different conditions, different background color. That's the main problem. And the third one is the various number plate designs. Across the regions, there are so many different types of number plates. For an example, like Malaysia, in Malaysia we're using a different kind of number plate system, number plate guidelines, and in Europe the number plate design is different, like different background color, different foreground color, size of the characters is different, the spacing between the characters is different. So this makes a non-uniformity in the system. And the fourth one is the number plate conditions. Like we know some has dirty number plates, some are the broken number plates, modified number plates, some these dirty and broken number plates, which let's say we got BND5610 and the D alphabet is actually broken. So the camera will actually extract the BN5610 only, because the D is broken, you don't know that there's a D over there. So this causes a huge problem in the ANPR system, which is a very big limitations in this problem. When we look at the current RFID system at toll gates in Malaysia, the first one is the usage is still in the development stage. It just fixed in 1-2 toll lines to in order for the testing, which is it's not haven't designed yet to work in a full in a large scale. And the second one is the system for now is only works as a payment gateway for toll collection. It is not intended to create the database system. So my project is about using the RFID technology for the detection. Every toll gate every toll gate lane has its RFID reader, and every vehicle has its own vehicle identity tag, RFID tag, which holds the information of the vehicle. Once the vehicle comes in, the RFID reader detects it, gets the information and stored in a database. That's how it simply works. The problem statement is that there are three main problem statements. The first one is the vehicle identification system. The vehicle identification system is still in the development stage, as not developed to work on a large scale. And the second one is there is no real-time database system to acquire the information of the vehicle passing the toll gate. And the third one is no user interface. So as an objective to eradicate this problem, my project is about develop a vehicle identity database, a vehicle detection system using vehicle identity tag and RFID technology. This is the first one. And the second one is to develop a real-time database on vehicles passing the toll gates via internet communications. And the third one is the user interface. So we will in this project develop a dashboard web page as a user interface to monitor the system. So to tell it in a simpler way, we will develop a vehicle identification system using the RFID technology. By identifying, we will acquire the information and store it in a database at the toll gates, which in real time using the internet communications. So as a user interface, we will develop a dashboard web page as a user interface to monitor the system. Okay, let me quickly jump into the most important part, which is the methodology. Okay, as a flowchart, there's actually the literature review will be on the first. So after we're done with the literature review, reviewing the previous related works and gaining knowledge about the related technologies in this project, to be in organized way, I have separated this into 5 milestones. Milestone 1, 2, 3, 4 and 5, and the last part will be the testing, troubleshoot, analysis. Okay, let me jump into the milestone 1. Okay, the first milestone. In this milestone, we will be doing the wiring connections between the ESP32 and RFID module, and then we will be develop the Arduino program code for the RFID detection system and upload into the ESP32. So when the Arduino IDE serial monitor, there's a serial monitor tab in the Arduino, when it successfully display the RFID tag serial number when it is scanned, which means the milestone 1 is a success. So then we will be jump into the milestone 2. This part is very important. At this part, we will be focusing on the setting up the Raspberry Pi 4, where the picture above shows the downloading process of the Raspberry Pi, and then we will set up the node rate. We will install the node rate in the Raspberry Pi 4. Below there shows some specific codes that need to be executed in the Raspberry Pi 4 for the installation process, and then we will be establishing the connections ESP32 and node rate. So the ESP32 and the node rate will be connected through Wi-Fi connections. Once the node rate shows the ESP32 as the connected device, which means the milestone 2 is complete. So in milestone 3, we will start the work with developing the flow-based program to display the RFID tag serial number in node rate. In the previous milestone, we have successfully connected the ESP32 to the node rate. Now we will be working on developing the flow-based program to actually transmit the tag serial number to the node rate, and then we will be developing the code, the Arduino coding on parameters that need to be transmitted and received via the MQTT broker. Once the node rate output tab, there's output tab in the node rate, when it successfully print out the display the RFID text number, which means milestone 3 is completed. So then we will be moving on to the milestone 4. In milestone 4, we'll be focusing more on the setting up the database. So here's where the development of database is started. We will set up the SQL server database, and then database server. In the database server, we'll be creating 2 databases. One is for the record database, and then one is the toll entry vehicle database. And then we will be develop the flow-based program to read and write with a read and write function. So in our project, we basically, when we get a serial ID number, we will actually read in the record database, get the information, take the information, and write in another database, which is the toll vehicle entry. So we need 2 databases. So we need the function of read and write ability for the database. So once when it's successfully, when it's scanned and get the information correctly, the milestone 4 is completed. Then we will be going on to the final milestone, which is in this milestone, once the database server is ready, now we'll be working on the user interface. So this milestone is completely for the user interface. We will set up the SQL node dashboard in the user interface, which includes the works of downloading the dashboard notes in the library, and then we will develop again the flow-based program to know which parameters actually needed to be show in the user interface. Configure the design and node rate, like pie chart view, bar chart view, which view we want, in which form we want the data to be presented in the user interface. Once the dashboard is completely ready, then we will be, once all the 5 milestones completely ready, then we will be moving into a section where testing, analysis, and troubleshoot. Here, where we do a multiple test on the to the systems to know how efficient it is. If there's any problem, we'll retrace back. This part is very important. The troubleshooting, the testing, analysis part is very important, so that we will know once the project is completed, we need to test it in order to know its efficiency and how it works and well. If in case we find out any mistakes or any undesired output, we will trace back the problem and solve it. So just let me give a quick introduction about the components. This is the ESP32, which uses a microcontroller, and the middle one is the Mirage RC522 low frequency RFID. It's a RFID module, and the right one is the Raspberry Pi, which uses a single board computer, which acts as a computer for this system, which is like a powerhouse for this. And software includes Arduino IDE for the coding, and then Node-RED for the coding, and also as well as the user interface as well. And the server will be using the SQL database server. Okay, now I'll jump into the preliminary result. So for as the outcome of the milestone 1, we have successfully done the wiring connections between the ESP32 and the RFID module. Then we have done the programming coding, and then successfully displayed the RFID serial tag number in the serial monitor tab. And then from the outcome of milestone 2, we have successfully connected the Raspberry Pi, set up the Raspberry Pi and connected it to the Wi-Fi. So this is the interface. This is to the Party TV application, which is a user interface for the Raspberry Pi. And this is the Fing mobile applications, which here we can see the devices that are connected to the Wi-Fi, connection. So we can see the ESP32 device is connected over here, and the Raspberry Pi is connected to the system. And this is successfully done in the milestone 3. We have successfully connected this connection, but this connected thing, which means the ESP32 has successfully connected to this. And when the card is scanned, the serial number of the RFID card serial number displayed on the Node-RED. So in conclusion, some people might be having a question why this database is needed, is necessary. The need of this database is crucial as the number of vehicles on board increases tremendously every year. The growth in this number actually causing some complications in cataloging the movement of traffic, which becomes an obstacle for the development of traffic. With this particular database, it helps in police investigations, like tracking down the suspicious vehicle activity, and also increases up the traffic security. So the system proposed was designed and developed with the help of many proven related research, which can be seen clearly in the literature review. The project was designed considering the area of cost, making it more practical in implementations, not only for the sake of just for presentations. I also considered an every sector of area to make it more practical in implementations. By using the Wi-Fi technology connections as a medium to transfer the data, causes less wire to be used, which results in convenience or in troubleshooting and maintenance process. So I prepared the Gantt chart for the PSM1. So it includes all the process of methodology and the milestone 1 and milestone 2. So currently I'm working on the milestone 3, and for the PSM2 we will be doing the milestone 3 and 4 and 5. Once they're completed, then we will go to the testing, analysis and troubleshoot, which will be go for 3 weeks. In that 3 weeks we will run we will be having a particular set of tests, like accuracy test, or response time test, the runtime test, interface test, final check. Once it's done, we will done with the result and conclusions. Hello guys, today I'm going to explain about the current progression of my project. This is the Raspberry Pi 4. This is the RFID module. This is the ESP32, which is connected to two LEDs. This RFID module and ESP32 are connected. This is the Arduino IDE, and I've set up the coding over here, and I've set the program the Wi-Fi details for it to connect to the internet. This is the Node-RED, and this is the Node-RED dashboard. This Raspberry Pi 4 and ESP32 are connected through Wi-Fi. Now I'm going to upload the program to the ESP32. Okay, now the ESP32 is connected to the Wi-Fi network, and also the MQTT connection is success. Okay, this Node-RED browser, I've been using the IP address of the Raspberry Pi. In this Node-RED, I have set up the flow-based program in order to transmit and receive data between the ESP32 and the Node-RED browser. Okay, now it is connected to the Wi-Fi connection. Now Okay, now I have 3 RFID card. When I scan the card, the unique number, the serial number of the card can be seen on the Arduino IDE's serial monitor, and this is the output tab for the note rate. This is the first RFID card, second card, third card. Now we can see the RFID card serial number displayed on both. So the data transfer is to the Wi-Fi connection, which is via IoT. This is the dashboard, which is the user interface for the note rate. I have set up a simple button to show that I can connect this LED over here. This LED over here I can control with the button in the web browser. Now when I click the button, you can see the LED turn on and off. It's turn on and turn off. This is I also can do in my phone also. Turn on, turn off. So this is a separate browser, which is the IP address of the Raspberry Pi. So as a wrap up, I have managed to transmit the serial number of this RFID to the Node-RED web browser via Wi-Fi, and also receive the signal from the Node-RED web browser dashboard to control the output of the LED.